start with our y-axis, and then we're going to introduce our protractor and get the z and the x-axis at 110 degrees. So opening up by 110 degrees brings us to there. Connecting that back to O. Looking at my sheet to see is this the Z or the X. It's labelled as the Z, so I label it as the Z. We'll do the same in the opposite direction. Opening up the angle by 110 degrees. And this is labelled as our x-axis. Then for there, what we'll do is we will take our, from the origin, I'll measure out horizontally by 35 millimeters, which is half of 7 meters. 10, 20, 35. Bring that down to cut the x-axis. And that gives us our position of A. AB is part of our axonometric plane, and it should measure at 70 millimeters, which it does. And how do we get C? So we have A and B. How do we get C? This angle BC of the axonometric plane, now this is key information, guys, this part of the axonometric plane must be 90 degrees to the z-axis. So how do I do that? So I'll take my sliding set squares and I'll take that skill set and I'll implement it into the question. So we have here x-axis and a 90 degree angle. We have our next line. I slide them along until I get to B, and once the set square touches B, I can stop and I can draw that angle in there. That indication is given to you in the question. It's given to you here by that symbol there and that symbol there. The x-axis and the line BC are 90 degrees to each other. Okay, so we do that one way. Now I have point C. I can join C back up to A, and I now have my axonometric plane. That is part A of the question completed. 6 lines. Part A of the question completed. Now, moving on to part B, it says draw the elevation and end view of as shown and complete the axonometric projection. So, I'm going to get the setup on the left and the setup on the right done. From now, that's the only, to get BC and AC, that's the only new information from what we've previously done. Everything else now is straightforward. So, the angle of inclination from A and C, what way will I do this? I'll do it this way. Is I set one set square up to the z-axis, introduce my second set square and hold it in place, and I'll slide that down to where I might need it. So down to the line A, slide it up to line B, or sorry, C, parallel to the z-axis, bringing it up, sliding it up as far as C. Once I hit C, bringing it across. Then AC must be parallel to its original line. So set up one set square to AC, introduce the second and hold it in place, and this can come out here. So now I have the line AC. How do I find the middle of that? Well, we use what's called bisecting a line. So I set my compass to over halfway, something that I know is definitely over halfway. The bigger it is, the more chance you have of getting over halfway. So we draw an arc one side, using A as our pivot point, draw an arc the other side with A as our pivot point. We move the pivot point to C, draw a third arc and a fourth arc, and then we connect them up. So I'll take my orange pen here, connect them up. This orange line is the bisecting line. Now, is anybody lost? Does anybody have any questions for me? That gives me the center, okay, of the line AC, which I can then now set my compass to. and draw that semicircle. Is that alright? Yeah? Now remember, I've got here is this plane, which is the YX plane over here. And then I have to do it over here, getting the YZ plane over there. So I need the Y axis. So I need a second point. It's going to go through point C. Where's O? So there's CO in the three-dimensional view. I need it in the two-dimensional view. Where is O? We'll continue the X axis on to hit the semicircle. And wherever it hits the semicircle gives you point O. Now that I have point O, I can draw a line from O through C, replicating the y-axis, which you know from maths, and then we take the O through A line, replicating the x-axis. Easy peasy. I'll do the exact same thing on this side of the page. So I'll set one set square up to the x-axis. Second set square is introduced. Hold the second set square in place as a pivot. That's your new t-square essentially. And then we're going to draw this line which is parallel to the x-axis. We do the same at C. Slide it up to C. Parallel line to the x-axis. Now I need a parallel line to BC. So again, bring in one set square. One set square is going to act as your t-square. The other one is set up to the parallel line. So slide it along. And now I have CB. I have to find half of that line, so therefore I need to bisect it. Set your compass to over halfway. Swing an arc on one side with the pivot at C. Swing an arc the other side with the pivot at C. Change the pivot point to B, swing the same sized arc. Join the 2 points that you're just after finding up, and that's your bisector. Now I have the midpoint. I'll then set my compass up to draw the semicircle from that midpoint. And I'll swing that around. So slightly off, just let me adjust it. Okay, and again we continue the x-axis on through until it hits the semicircle, giving us the origin point, labeling it as O. Okay, and then we will join C to O, or O through C, giving you the y-axis, which are all height dimensions, and we'll bring O through B, which are going to be our z dimensions, or our depths. Okay, that's our setup, and that's the setup for every single question. The only thing that's going to change or vary is the angles in here and the information coming down. Okay, and now I have to draw the two profiles. So we have the front view of the goals, which is 8.5 meters. The scale is 1:100, so take 8,500 divided by 100 gives you 85 millimeters. So I'll measure my 85. The overall height of the object we don't know just yet. I'm going to show you how to get that now. So the only information I have is that's as much as I can get in that view at the minute. I can just get the width. Okay, and to draw my vertical line here, so the goalpost starts on the ground and goes up. I just don't know how far up it goes yet, but I'm going to show you how to find that information. So going over here, we look at our image here. Now, watch this. We'll zoom in on our question. So, we have here that this is 4 meters in radius, which means I can step out here by 40 millimeters and bring that up. Okay? And the center point of my arc is going to be wherever that vertical line crosses this axonometric plane line, BC. That gives me the pivot point for my arc. And the arc will then stop when it hits this horizontal line, which is 1 meter wide. Okay? So there's a lot of information to digest in that, but it's all given in the question. You just have to understand how to read it. So now we're going to go back to our question here. And radius of 4 meters, which is 40 millimeters. So stepping out here by 40 millimeters. Sliding set squares will create the vertical line or the copy of the y-axis that I want. Okay, and then wherever it hits here, that's the pivot point for my arc for the goalpost radius. So I'll set up my compass to radius 40 millimeters. Put the pivot point there and swing the arc. Then I'm going to step out by 10 millimeters here and then draw another replica vertical line of the y-axis. So I have my set square set up to the y-axis. From that 1 meter out, I cut it, and that tells me where the arc stops and then where the horizontal line begins. So I set up my set squares again, sliding set squares from there and from there. And just for the purpose of this, I'm going to put them in black to make it stand out. Finished lines. And I'm going to take that information that you're just after finding and you're going to transfer it then to over here. So your overall height, which we're used to doing this from our auxiliary views, we take the height of the goalposts with our compass, that's a measurement, and we transfer it over here. Now we know the height of the goalpost over there. Set squares are set up to the base or the ground line or the X dimension. And we bring that across to create the top of the goalposts or the crossbar, and then this would be so that is what you're asked to do for homework for today. And now we're going to combine these to get our goalposts in the middle and tackle the last part of the question, which is a brain teaser, okay, which is easily done for everybody. So I'm going to use my sliding set squares here. So I'm going to set up one set square to the z-axis, like so. The other set square is going to be held in place as my anchor. And I'm going to bring the points of the goals down at the same angle as the z-axis. Do the same thing in the opposite direction going over this way. So setting this up to the x-axis and bringing it to the points of the goalpost that I need going this way. Now, from our previous question, so I'm just going to fill in what detail I can for the vertical elements or for any straight line elements. So our goalpost would start here. What can I do to benefit this drawing and to maybe promote good habit? Labeling it, okay? So on the sheet, you don't have to draw a 3D sketch all the time, but on the sheet here, I might label this. So if we zoom in here, I can label this 3D graphic, and this could be point 1, 2, 3, 4. Then we have 5 and 6 and 7 and 8. These are only the straight line elements. So I'll take those labels, alright, take those labels and transfer them to the two-dimensional views. So
you do the part C.
We're going to do that now in a second. Yeah, I'm going to show everybody how to do that. So this is point 1 and 2. Up here is 5 and 7. Over here is 6 and 8. And this is 3 and 4. Over here, according to my labels, this is going to be 2 and 3, and this is 1 and 4. This point up here is 5 and 6, and this point here is 7 and 8. Okay? So those numbers and those numbers are going to combine in here to find me what I need. That is point 1. That there is point 2. That there is point 4, and that there is point 3. I've now found my 4 base points. The goalposts start on the ground and they go up as far as point 7 and 8, which is there. Now, which is here. That's point 8. Now let's just test that theory. There's point 8, bringing it down here, hits the exact same spot, so I'm bang on. Okay, goalpost goes at 1 and goes up as far as point 8 or 7. And again, let's test the theory. If I bring 7 from here, where does it stop? Well, it comes down that way. So there's 7 coming down that way to hit that point. There's 7 coming down that way to hit that point. So that's my crossbar going across there. Then the back support for points 5 and 6 will go back as far as here. And here, and then there's a bar going across that way. Two goes up as far as here. And if I take this height, transfer it. That'll give me that information there that I'm looking for. So take that orange line, copy it, bringing it from there. Tells me where to stop. Okay. And now what I need to do is I need to do the curve. So what do we do to split the curve up? How do we do that? Knowing from our previous questions. How do we split this curve up? Like a clock. A clock is split up 360 degrees, is split into 12 sections, which is 30 degrees. So every 30 degrees we're going to put a mark. So from the center of the clock, which is the center of the radius, we draw a line like so. And then we'll go at 30 degrees from that point as well, like so. We'll number it. Maybe this could be A, B, C. Have I found A already? Yes, I have. I need to find the second point of A. So this is A and A. And what we'll do then is for B, we'll find the height. So B has a certain height. We'll bring that down and we'll use that height and transfer it over here like we did for the top of the goalpost or for the crossbar. That height is going to be transferred over. So we'll take that height of B, taking the height of B on that curved section, and we'll transfer it over here to there and to there. Connecting them up gives us the height of B, which is the curved section. I'll label that as B and B. We'll do C as well. So the height of C is going to be marked using our instrument, which is our compass. Mark that in, transfer it over. There's the height of C. There's the height of C. Labeling them in, C and C. And we'll draw them with our set square. So now we have 6 points to find. A and A, which we've already found. B and B we haven't found down here yet. And C and C. So let's find them one by one. So A and A we've already found. B and B we have to find. So we'll set up to the x-axis, bring it up to B, and bring B down at this angle, the set angle. So BB has to be somewhere along that line. We'll do the same thing in the opposite direction here. Set this up to the z-axis. Bring it to B on one side of the goalposts on the side, and bring it to the other side, all transferring down at the correct angle. So where does B meet B? Where does the B line meet the B line? It meets it there. Where does the B line meet the B line? Meets it there. We'll do the same thing for C, and then our object is solved. We just have to do the last conundrum of part C of the question. So we'll take point C here, or points C, and we'll bring them down at this selected angle. We'll take the points here of C, and we'll bring them down at the selected angle. Oops. And then wherever C meets C, we put in as a dot. So there's C going this way. Where is C that way? There. Label it in as C. Our goalpost goes like so. That's one side of the goalposts. And the other side of the goalpost, there's C coming this way and C going that way. Where do they meet? They meet here. So therefore that goes from there to there to there to there. Goalpost sorted. Just draw the back of the goalpost, or the net section, which is the furthest point away, and you now have your goals drawn. Part A and B of the question completed. Do we understand that? Yes? Then part C of the question is: a ball is positioned on the ground at F, point F, for a kick. Point F is 9 meters away from the goal line and is located in the direction shown. So wherever this green axonometric plane line, if you look at the question, let's zoom in and show you how you solve this. So this is point F, and we come out by 9 meters. Point F is where the front line of the goal line, meets the line AB. So wherever that is, that's that, and we come out 9 meters. So, first off, what I'm going to do is from the goal line, which is here. Oh, sorry. See that? From the goal line in this view, I'm going to come out by 9 meters, which is 90 millimeters, which ends up being here. That's where the ball is, okay? That's where the ball starts. 9 meters away. And this is here, our path. So, I can bring it this way. How far do I stop, or how far does the ball come out? Well, I'll copy all my other angles for all the other points, and I'll go as far as where the ball sits in this view. And I'll bring that this way. And that's where my ball is sitting. Do we all understand that? So far, yeah? Okay, and the question says the path of the ball after it is kicked is a parabola which reaches a maximum height of 6 meters. So I know that if I measure up here 6 meters, this is the maximum height that this ball will reach. That red line going across is the maximum height that that ball will reach. Ball starts there and reaches its maximum height, which is 6 meters above the ground. Now it reaches its maximum height of 6 meters above the ground, having travelled a horizontal distance of 6 meters. So it says 6 meters, we convert that by scale, guys. Remember, all these meters is scaled down to fit on our page. So 6 meters is 6,000 millimeters. Divide that by 100, that's 60 millimeters. So after 60 millimeters, 1, 2, 3, 4, 5, 6. This is what we call the apex, or the vertex of the curve. So this here is known as the vertex. Okay? That point is known as the vertex. It is the peak of the path of the ball. Yes?
How'd you get the vertex?
So I just followed the information from the question. It said that the ball was 9 millimeters from the goal line, and it said it will reach its maximum height having travelled a horizontal distance of 6, and the maximum height will be 6 meters. So that's all I've done. Does everybody understand that? Everybody understand that? Okay. And so what I'm going to do is, if you didn't know this before, you're going to know it now, is how do we draw a parabola? This is new information, not overly essential for now. We haven't learned it, but it's no harm in doing it. So now we know what the term parabolic means. So what we're going to do is, with this square, or rectangle, apologies, it is a square actually, it's 6 by 6. With this rectangle, we're going to split it up. So we're going to do a thing called division of lines. So we're going to take the line between M for midpoint and B for ball. Okay, I have V for vertex, M for ball, or M for midpoint, and B for ball. I take the distance between M and ball, and I split it up into 4. Are we listening? Everybody listening? We split this distance between M and ball into 4 or more. Whatever that distance is, if it's easily divisible by a number, we can just simply put in the number. So 60 millimeters, is that easily divisible by 4? What's 60 divided by 4? 15. Yeah? So I can just go every 15 millimeters. So I don't actually have to do division of lines method. Do you guys understand? So, and then the height of it is 60 millimeters as well. Is that easily divisible by 4? Yeah. I could use 5, but 60 divided by 5 doesn't give you a nice round number, does it? No. So, I'm going to go 15, 1, 15, 2, 15, 3, and another 15 gives you 1, 2, 3, 4 divisions. Do you understand that? I'm going to do the exact same thing for the height. 15 millimeters, 15 millimeters, 15 millimeters, and that gives us 4 sections. Now, when we're doing a parabola, this is what we call our axis. That's the symmetry line. So you know that when you throw the ball up in the air, when it goes from here, that's a base point, it goes up in the air to its vertex, the other side is symmetrical, it's a mirror image. Yeah? So this means that this is the axis. Is that alright? Now, when you're doing a parabola, your lines always go, one set of lines always go parallel to the axis. And one set of lines go to the vertex. So these 1, 2, and 3 are going parallel with the axis, and the other 1, 2, and 3, sorry, that should be 3, 2, 1, they go to the vertex. Can you see this on my page? You can, yeah? Okay. So 3 goes to the vertex, 2 goes to the vertex, and 1 goes to the vertex. Have you got your parabola? You've half the parabola. Ball starts here, it's kicked by, we could say Messi or whoever else is a good free taker, okay? Where 3 crosses 3, that's the next point where the ball will be captured. 2 where 2 crosses 2, where 1 crosses 1, and the vertex. that path is your half your parabola. Now can we copy that to the other side? Can we mirror that?
Yeah.
How do we mirror? Do we know how to mirror? Compass, good. And the question that the solution that you're looking for is the question in the page. It says, by drawing the parabola in the end view or otherwise, determine whether the ball goes under or over the crossbar. I've drawn half for you. Can you draw the other half and determine will that ball go in the net or not? Okay? Copy it, I'm going to take this distance from the symmetry line, copy it over. Those of you that have done junior cycle graphics should know how to do this. Those of you that haven't need to catch up. Now, there's the path of the ball, there's the path of the ball. Is it a goal?
Yes.
Solved. And if you needed to, you could do it here as well, but you don't need to. That's that question. We have one more to do. I'll give it out to you now in 2 seconds.